Hello, everybody. Hello, thanks for having me. My name is Nikos, and today I am going to talk to you about Azure Digital Twins, Azure IoT, and some majestic robots. Thanks for having me, and I really hope that you enjoy the session. So, before starting, big thanks to our sponsors. I am a big fan of community events. I try to take part in as many of them as possible, and I know that they would not be possible without the assistance and the help in every possible way from our sponsors. So, big thanks to them. Uh, just a couple of words about me. My name is Nikos Delis. I am a senior cloud engineer, a freelancer, and I am based in Malmö, Sweden. Malmö is the third largest city of Sweden. It's right next to Copenhagen in the southern part of the country. And as you can imagine, I work quite a lot with Microsoft Azure. I have a few certificates that verify my skills, and I also have a blog called ND Technique, as you can see it here, .com. I am doing a podcast which is called Azure Triumphs, stories of people who succeed with Azure. And I am hosting that in Spotify. You can also find it in Google Podcasts and Apple Podcasts and everything. And together with a few other very skilled and happy people, we are running Azure Skåne. Skåne is the Scania region, the south part of Sweden, and we're having events around once a month with various experts talking about various Azure related matters. I'd be very happy to connect with all of you. You can find me on Twitter or X with my handle called And the Technique, and of course also on LinkedIn using my name. So let's get into today's session. So we are first of all, I'm going to explain to you what are the robots that I'm going to talk about. Like, of course, they're robotic arms, but they are actually a lot more than that. Then I will try to explain you why you should bother doing all those things if you're working with IoT and if you're working with robots and all that stuff. Then I'm going to analyze the kind of data that we collect and what we're doing with those. I am also going to tell you where we store all those things and why we do that. And last but not least, I'm going to show you a happy little demo with Azure Digital Twins. Now, about that last part, it worked yesterday, but I had to restructure today. So we might have some surprises, but let's hope that everything works fine, right? Okay. So, in all my presentations, I always talk about the projects that I work with. I never hold sessions pretending that I'm like the biggest expert on something. I am just giving you my view and the ways that I solved the problems that I had. And maybe someone can relate or be inspired or, I don't know, find them interesting. So, today's project was done with a company called Rebel Industries. It is a Swedish company. They're based in a small city called Skövde, and it's like an hour or so from Gothenburg. And they are offering workmates. Yeah, they are workmates. They are sold by hour, like consultants, like people consultants, and they are actually selling a skill. So, as I mentioned here in my slide, they provide a preset, engaged, and effective workmates. So, what kind of skills, I hear you ask? This is one of those, random depalletizing, which is the act of emptying a pallet. So I believe that everybody has seen those big wooden Euro pallets, which are carried in trucks and used to place very big packages upon, and then every time you move something in bulk, practically 99% of the times, you're using Euro pallets. So those pallets have packages or boxes upon them, and they have to be moved from the pallet to a band or something. I will show you a video in a few minutes that you will definitely understand. And This specific robot that we're going to talk about today is managing to place over 600 packages per hour, and that's a lot. That's more than 10 packages per minute. And as I mentioned, they are big and they're heavy. So it is very good thing that that the robot takes this task and not a human being, because the human being could injure their back. There's very high probability of things going wrong. The packages are getting injured as well. So it's better to assign this dull, boring, and heavy task to a robot. Then it's a very good deal for the customer because they only pay for the time that the robot is performing its duties, and they have a very short lay time, with everything that's happening in the world and the shortage in all the various parts. It's not easy, and nobody actually can guarantee that they can deliver the robots in a good time. But Rebel Industries have done a very good job, and they have a nice inventory, and they can deliver those workmates in a very short lay time. The robots are, of course, very well trained because they have a big studio there in Hövde, where they explain to the robots the moves that they have to do. They are training them in real life data. And when the robot arrives to the customer, it already knows what to do. And of course, they have a lot of security measures to make sure that this noble giant will never injure any humans or anything else, actually. And to be a little bit more specific and to put it into perspective, this is a workmate. This is called Clipson. And as you can see, it's way more than just a robotic arm. And I don't know if you can see it by the background, but this guy is standing more than 3 meters from the ground. So it's very high. It weighs, I think, around 600 kilos. And then it has a cement block that it's standing on. And I think that this weighs a ton or something. Then it has a very big industry sized computer, and it has an overall control system, PLC, and various robotic parts. It has a lot of sensors to help the robot to perform its tasks, but also sensors to make sure that if humans come close, then the machine human safety system will be engaged, and then the robot will immediately stop whatever it's doing. Then, of course, it has a number of cameras on it and a 3D scanner, which gets a point cloud. It's like sending down infrared beams to locate packages and to see where exactly they are in the space. And then, of course, we have the whole robotic arm, and we have the tools here in the tip. You will see it a bit closer. And before getting into the Azure stuff, just a short video. I believe that you can also hear the sound. So what we see here is that the robot is waiting for the package to move, and now it's placing it peacefully and very gentle on the band, and it's picking the next one. As you can see now, it will go very fast home, but it will pick the package, move it slowly, put it on the band, pick the next. Now, while it is in the posing, while the robot is in this position, maybe you noticed a red flashlight here from the sky. It's not actually from the sky; it's from the upper part of this installation, and it takes a photo of the stack. You can see the Euro palette here on the bottom, and it takes a photo of the stack to understand how the packages are stacked. So while Calypson is moving the package to the band, the system is taking a photo of the remaining stack to find the next package to pick. So there it puts and it goes to pick the next. Again, photo, now it waits. As you can see, it is waiting, and it's waiting because the band isn't moving. So it wouldn't put a package on another package. See, it waits, it waits, it waits, it waits. Now it moved, now it replaces. Yeah. So as you can imagine, and now we're getting into the main part of the session. A lot of questions arise about all these things, like how many packages they do this. Do this is on the robot pick today. How fast was Adam? Is Mimi's disk full again? Or what is the success rate of Ole's pick and place task? And we can also ask the robots to go update themselves. And obviously, all those things are happening based on events. And I can hear you asking, okay, but what is an event? And practically, an event means that something happened. But on that, if we take a little twist on that, I can also say that even not happening something is an event. So maybe nothing happened, but time passed. So time passing could also be an event, right? So that the robot did something, that the robot is waiting for something, or that the operator did something, all those are events. And what we want is to get information from those events, to understand them, to make useful decisions based on them. And the decisions could be everything from statistics, from verbose logs, and for getting information to use for preventive maintenance and to fix things before they actually break, but even to count how much skill the robot has performed to get paid. So for all those things, we have this overall architecture. So the robot is producing data, and the data are sent in this central computer, and those are stuffed together. They are in the same box, as you can see here. Then from the computer, somehow, and we're getting to that, the data has to move to Azure. And then from Azure, we want to display them in a portal, and we want to present them in Grafana. Grafana is an open source presentation tool, a very, very nice one. You should definitely check it out if you haven't used it yet. And of course, we need to save all this data in someplace safe. So when I started in this project, this was the software topology. This was everything that existed. So we had the hardware part, as you can see, the yellow box here. And here we have the robot, and we have this very big Balak computer that I showed you earlier. And then we have the software part. So the software lives in the computer, of course, not in the robot. And the events that are produced from the robot and from all the other components that are living together there, they are being sent to an MQTT, mosquito as some people call it, a message broker. So what is such an event? Well, this is what an event could look like. Actually, two of those in this case. So I took them from Mongo. So this might look familiar for some of you. And we have a very simple JSON object. We have a topic, and this one is called Rebel Controller, Robot Station, Awareness. I like the word awareness because it's helping us being aware of everything that's happening. And this is an event, but it could be a status as well. And then we have the message. And every message has a publisher. This one is from a generic called Other Resources. And it was published at like a little more than a year ago. And then we have also the awareness part, and that one was a package placed. A value, this is in this case, it is the ID of the package. And we also have a UTC timestamp of exactly when this thing happened. And then we have the next one. So all those events are being sent in the MQTT message broker. And what we can do is that we can subscribe on those topics. And that's what I did, actually. So I built a very little .NET Console application, which I called the agent. And I installed it on this very robot. And this is why it is still in the same box. And I also made sure to install a Mongo database. And obviously, I picked the document-based database because the event types are changing all the time. I have no guarantees that I will have a schema that will remain the same. So I just wanted something to dump all the data inside. And then from there, the agent is using a private endpoint to send everything to Azure IoT Hub. And Azure IoT Hub is like the event hub with some nice IoT twists. I will explain later. And from there, I had a stream analytics job that took over the events and did a lot of stuff on it. And this worked quite nicely, I have to say. There wasn't many issues. There wasn't actually anything that could break, except that I did that in my own environment, and sometime I had to install it on the robot. And on the robot, you only have SSH, you don't have a graphical user interface. And I realized that I would have to install .NET, the .NET framework. It's like the .NET SDK everywhere. And since it's Ubuntu, it has to do it in a specific way, and I found that to be very, very tiresome. So quite fast in the beginning, I realized that we have to containerize this application and actually containerize even Mongo so that we can easily deliver it. It's easier to install Docker than .NET, and I could take for granted that Docker would exist in all future robots. So I just containerized the application, and then I also simplified the update process of the agent. I had my source code already on GitHub, so I made a little pipeline which deployed the source code of the agent in Azure Container Registry. And then with a simple Docker pull and Docker run, I could make sure that the latest version of my code is running on the agent. Now, all this is very nice, but if you remember from the beginning, one of the questions that arises is how are all the other components and not only the performance of the robot? So in this computer, we have hard disks and we have other components, and they can also face issues. So we have to gather information such as memory usage or CPU usage, or in the worst case, the hard disks, which can get full, and then we have very, very big problems. So first, I tried to gather this information by the agent using native .NET tools, and this actually didn't fly very well because since I'm running in Docker, Docker acts as a virtual machine, and I only get information that derives from that machine. It's like a computer inside a computer. So what we did was that we created a node application this time, which was using some relative libraries to gather the information from the computer. And this time, this wasn't installed in Docker, this wasn't containerized, it was installed directly in the machine. And being written in Node, which is why it was written in Node, we didn't have to worry a lot about having to install various frameworks. Node is pre-installed in Ubuntu, so no problems there. So how is the agent going to talk with the spy, as this one is called? Well, it is a Node application, and what we do a lot with Node applications is running servers. So it exposed a small endpoint called get status or something irrelevant, and then the agent it can understand localhost, and if you use the hosts network, then what is localhost for the spy is localhost for the agent. So it could very easily talk to it like any RESTful API. So the agent was getting the status from the spy, and the spy was gathering information from the computer, from the host computer. And then the agent, following the same road, could send all this information back to the cloud. So now we have everything. We have the agent picking the messages from MQTT and sending them to the cloud. We had the agent talking to the spy gathering information from the host computer, returning it back, and then sending it to the cloud. Everything is very good. What could go wrong? I hear you asking. Well, what could go wrong is many things actually, but what went wrong is that sometime for some reason, if I remember correctly, I tried to create an index in this Mongo database, and it didn't go very well, and it actually pretty much died. And we realized that if Mongo is dead, then pretty much anything is dead, and we don't even have the backup. Now, having already sent the data in the cloud, we didn't have like a huge problem, but we realized that it's not safe enough to have all verbose data just in Mongo, and it lives in a container in Docker as well. So we created another application again with .NET, again a console application, and the only thing that the ankle, as it's called, the only reason why it exists is that it takes a copy of data from the collections in Mongo, and it is sending them to the cloud. And here comes the interesting part. Now, we didn't want to have a Cosmos database because this Cosmos database costs. We didn't have to have actually any kind of database. We just wanted to have backups. And in case they were ever needed, then we wanted to have a simple way to fetch them. So the ankle can pick data from Mongo in form of JSON, and it is sending them to an Azure function, and the Azure function is converting them to blobs. Yes, you understand correctly, to blobs, saving them in Azure storage. And then we also are using the life cycle of Azure storage to make the older blobs move to colder and colder tiers, thus making them cheaper and cheaper with the time. So the basic logic behind that is if a blob containing verbose logs is older than a week, then it is rather improbable that anybody will need it. Because if something breaks, if we lose data, then the guys are going to get notified pretty much immediately, in worst case within a few hours, and they're going to have fresh data. And if the data gets old, then this means that nobody needs them. So after a week, they get to cool. After 2 weeks, they get to cold. And after a month, they get to archive. So we have a load of gigabytes for very few euros in this Azure storage. And everything else remain the same. So a small summary on how we prevent data loss. We use three things. First of all, the moment the data is generated here, we save it directly to the Mongo database. So even if the agent is losing connection to the internet, even if for some reason their agent crashes, in the very first row in the code, what is done is that it is saved in Mongo. So we can always restart the agent, reprocess the messages, send them again. Then, after this is done, then we're sending them to the cloud. And from the cloud, we present them in Grafana, we present them with digital twins, we even send some heartbeats, some data in a Cosmos database. And last but not least, we have the ankle to take backup of the verbose data, send them to Azure function, and save them in Azure storage. So in this way, we back up everything. We have at least one offline backup here at the robot, and we have a couple of cloud backups, one in storage and one in the various other destinations. So data by itself doesn't say a lot. To give life to data, you need to process them. You need to understand what data means. So we do some pre-processing on the edge, and we display them on the cloud. We could do all the processing on the cloud, and we used to do it actually, but quite fast we realized that this is taking unnecessary resources because we have a heavy industry-sized computer on the side of the robot, and we can do some simple calculations like all those per hour statistics all those mean values, all those simple calculations. There's no reason at all to do them in the cloud. So we do all this pre-processing at the machine, and we're sending processed data to the cloud. So the result of all this is that the operator, so the people working close to the robot, can see something like that. This is an image of a digital twin, and I will get back to you in a few minutes. And this is a verbose log. And now observe that these happen in the same second. This is how fast the robot is normally. So we have a packet started, packets placed, then getting the length, the width, and the position Z, like the height of the next packet. And then 4 seconds earlier, yet another batch, and 4 seconds earlier, yet another batch. Then we have the stakeholders, the people who are purchasing this skill. They are also interested in seeing how the robot is performing, and obviously they need another view. And this view comes from Grafana. This is the presentation tool that I mentioned earlier, and it's a great one. It's open source. There is an enterprise version as well, but for our needs, we can do everything we need with the open source version. And we have deployed in a simple web service, which is reachable only from the IPs we want. So it costs very, very little, close to nothing. And we can do very complex data presentations there. And for the people working at the lab, we also have these kinds of graphs again in Grafana, but as you can see, those are way more complex, and you can also use all the data tools to dig into the data and to understand what happened when. And you can always, when you find a time window, like here at 8:30 when something got wrong, or as you can see here, we have a big gap. Now, obviously, you can see with the bare eyes that something was wrong there. So you can find exactly when something was wrong and go back to the verbose logs and see why what went wrong. So we couldn't have done most of those things without the Azure IoT platform. And the end architecture, or by end, I mean the current architecture, is like that, only from the cloud perspective. So forget about the robot. This is what's happening in the cloud. So we have messages coming to Azure IoT Hub. And as you saw in the title of this presentation, we're talking about a farm of robots, not only one robot. We have all of those messages coming to the Azure IoT Hub. We have an Azure function which uses an event trigger, picking those events and sending them to the digital twin. And you will see in a few minutes why this is very, very fancy. Then in the same time, the Azure IoT Hub is delivering those events to a stream analytics job. And that one is saving this data to PostgreSQL databases and to Cosmos databases. And depending on from which robot the message is coming, it is being saved in a different collection in Cosmos and a different table in Postgres. And then obviously the Grafana tables are connected to those databases, and all the data that is displayed there derived from those tables. So why I say again and again that the tools in Azure made our life easier. So starting with a hub, it has implemented already the message-based architecture. Actually, today, it wasn't the case when I made this presentation, but today you can even use MQTT, which makes it that you can use even MicroPython, which a very light version of Python to send messages. And this is a great thing because you don't need to have very advanced components to send your data to the cloud. You only need an internet connection and a very simple machine. Then we have the plug and play devices, which you can use with Azure IoT Edge. and this is a small framework that you can install on your device. And the moment you put a connection string, everything is ready to play. It has multiple integrations. It can send its data to the Data Explorer, to event hubs, to the Stream Analytics job, and it has multiple SDKs also. So the people at Microsoft have created a lot of SDKs for us to use. You can use it with Python, you can use it with JavaScript, you can use it with C Sharp as I did. There's a lot of easy choices for you. Then, as I mentioned, we use the Azure Stream Analytics job. And if you ask me today, I wouldn't be very sure if that would be the best solution, because you put an extra cost in the middle. You could send directly all those data from the hub to a database. But what you win with the Stream Analytics job is that you can make channels and send data to different destinations. You can filter, you can also do some pre-processing, some aggregations, some other very interesting stuff. And then the best thing about it probably is that you can always pause and rewind. So if something is doesn't work very well with your query, if the data doesn't go where you want them to go, then you can always pause and restart from a different point in time so that you can reread and reread the data. And then all of this wouldn't matter if we couldn't display the data. And the best way we could find was to use Grafana, because it gives us a very easy access control. We have actually integrated with Microsoft Entra so that we can choose who has access to each view. We have even customers there. And then the digital twins, they give us a very quick overview, and we can very easily understand how to do stuff if something goes wrong. Then, and I'm closing to the end of my session. The digital twins are not very easy to get started with, and here I'm giving you a starter pack. This is how you get started. You have to create your models first using the DTDL, the Digital Twin Definition Language, and it's not very complicated. It's like a box in a box. You say that first you have an organization, and then inside your organization you have your farms, and then inside your farms you have your robots, and you can do it like that. Then you have to create a twin by importing some dummy data, and that's what I'm going to show you in the demo in a minute. You also need the 3D scene, and this is something that anybody can do with AutoCAD or any other similar modeling tool. And you can connect your models with your twins. I will show you how in just a second. And then you create behaviors. And those now I think it's a good time for me to show you what I mean. So I'll just zoom in. Now, I hope that this is visible. As I can see the screen, it looks pretty visible. So this is an Azure Digital Twins resource in Azure, and I'm going to the Digital Twins Explorer. So if the demo guides are with us, it will work fine. Okay. As you can see, I have already deployed my model here, and I have organization, I have robot, and I have the robot farm. So I have already done this uploading part that I told you earlier. And if I run my query, then it should display exactly what I told you. First of all, we have the organization. And in my case, I'm clicking on this purple point. This is Rebel Industries, and it is an organization, and the only property it has is a name. Then I have two farms. The first is called the lab, and the second is called customer. And now customer in service is called Kunden, which is why you can see this name here. And the lab is called Labet. And then I have two robots. One robot in the lab called Adam. And if I click on it, then you can see that I have a few more properties. Just a second. And I also have Black Panther. also with three properties. Now, of course, digital twins are more than that, but this is a good visualization of how things are hanging together, how things are connected together. So getting to the 3D scene studio, which is what's stuck previously, and I hope it doesn't now. Okay, that's good. I have a demo scene. It's loading the model, and now we are in build mode. Now to make it a little bit more fancy, I'll try to put those things next to each other. Okay, very good. So as you can see, using drag and drop, I can move around, and this is my 3D scene created on AutoCAD or something. The robot guys do that. And as you can see, I can click on all those things. And by clicking, if I click on this part of the robot, for example, I can create, call this an element. And by creating an element, I can add behaviors on it. I have already created that actually. And it's called Black Panther. And it has a couple of behaviors. It has one called change color by status. And if we edit that, you can see that it gets green or red. And when does it get green and red? It gets green if the property status int in for integer, this one, is from 1 to infinity, and it gets red if it's from minus infinity to 0.9. So if we go to view mode now, and you can see that this is 0, then this one is red. And if I click on it, then you can see that the status is stopped, and this comes from here. And the color is red because the status int is 1. So if I change this to running and this to 1 and save, now it was saved. Yep, as you can see, pretty much immediately the color changed to our twin as well. And now the color is green and the status is running. If I change it back to stopped again, and this to 0, and I save, then let's give it a couple of seconds. Yes, red, and the status is stopped. So I understand that this is a very simple demo, but imagine that the changes that I do here can be done with an API. And they are very, very easy to implement, and they do very big difference if you have more. Like, I don't know if I can show you a Microsoft demo using yeah, like this. This is a farm. So can you see what people can do? This one is red. So, sorry, already now understand that something's wrong. And you can see box 781 was missed, please check. Or this box 451 was missed, please track down this box. And if we check something more fancy, the robots, the space station, then you can see here as well that we have dangerously high temperature to humidity ratio. And yeah, you can make very important decisions based on this data and making them visible. It's very easy to have call to action. I guess those would have to be the finishing words of my session. I do hope that you enjoyed it, and please rate my session. Thank you very much.